Have you ever wondered how the thing we rely on every single day, basically the entire internet, can break from a single mistake? Today we are talking about the silent backbone of the internet, the Border Gateway Protocol. A protocol so powerful that one wrong update can take down global giants. Think of the internet as tens of thousands of independent smaller networks. ISPs, cloud providers, universities and enterprise systems, all stitched together. Each of these networks operates autonomously and owns a portion of the global IP space. To communicate, these networks rely on routing configurations. And BGP's core job is simple. It allows each network to advertise which IP prefixes it can reach and through which path they are reachable. In other words, BGP answers the question: if you want to reach this part of the internet, send the traffic to me. From the earliest days, the internet was designed to be resilient and fault-tolerant. If one connection or path between networks fails, the routing system would automatically choose another available path, so communication continues. And here BGP comes to play. But this resilience depends on accurate, continuous BGP announcements. If a network stops advertising its routes or advertises incorrect ones, other networks will no longer know how to reach it. When that happens, the network effectively disappears from the internet, even if its servers are still running. And here's the catch: BGP is based on trust. Routers trust the routes they receive, and that trust can be dangerously fragile. To wrap this up, what happens if you publish the wrong route? Simple: you disappear, or worse, you make huge parts of the internet disappear with you. And that is exactly what happened to Facebook in 2021. On October 4, 2021, Facebook, Instagram, WhatsApp and Messenger all went offline worldwide. Not for seconds, not for minutes, but for almost 6 hours. That's one of the biggest outages in the internet history. So, what actually happened? Facebook engineers pushed a routine BGP update to their backbone network. The update accidentally withdrew all BGP routes that taught the rest of the internet how to reach Facebook servers. Facebook owns multiple networks in different regions, which are used by their data centers. They even own the internet DNS servers responsible for hosting Facebook DNS zones. With the BGP routes gone, the paths to the Facebook DNS servers were also gone, and they become unreachable by other DNS servers. With DNS unreachable, browsers and apps couldn't resolve domains like Facebook, Instagram and WhatsApp. And that was what the users saw initially. The DNS names of Facebook were no longer resolved to IP addresses. But in fact, not only the DNS servers were unreachable. The whole infrastructure placed in each Facebook data center was also unreachable, even for the Facebook internal monitoring tools. The remote access to the systems was also down. Engineers literally had to physically go to the data centers to restore the connectivity. And this was hard, as the system responsible for the security badges was also inaccessible. There was no issue with the services themselves. They were functioning normally. They just could not have been reached from the rest of the internet. In other words, Facebook didn't just disconnect itself from the internet. They disconnected themselves from their own ability to fix the problem. And that's how catastrophic a single BGP misconfiguration can be. And you might ask, why does something so critical rely on trust and is prone to human errors? Because BGP is old, like 1989 old. It was designed when the internet was small, friendly and built by researchers. Security wasn't the priority. So, the next time your favorite app goes down, remember, it might not be a server crash. It might not be a cyber attack. It could be one tiny line in a massive routing table, causing global chain reactions. If you enjoyed this breakdown, hit like, subscribe and let me know in the comments. Which network outage do you want me to explain next? See you in the next video.